Okay. Hello, everyone. In our project, we will show you and explain step by step about pre-stack inversion, inversion analysis process, starting generate initial model to inversion analysis, also usage of cross plot between the inverted properties to identify the reservoir. We have four parts and we share. For the introduction and conclusion part, will answer me as Hat. For parts, selection of pre-stack seismic, setup velocity model, angel gazer, select wells, and select horizons, will answer Yana. For parts, extract statistical wavelet, correlate the wells, build the initial model, inversion analysis, and apply to volume, will answer Mira. For the last step, final part, it's a usage of cross plot between the inverted properties to identify the reservoir, will answer Enoch.
Okay, everyone.
I think you can start.
I'm Norena. I will explain to you how we we select our pre-stack data. So before we start for we select for our process of selecting pre-stack data, we go to the workflow and then select the pre-stack inversions. Then you can select the pre-stack seismic. After that, the other sections will be pop up, and then you need to identify is it the true type. Select the pre-stack type, and then you need to find the data that we need to generate the pre-stack. For here, for our task is we select the super gather, and then select the super gather. After that, just select, and then the pre-stack will be generated. And then we select this set up a velocity model, and then we need to find look at the uh, identify the parameters, select the new one for changing the velocity field, and then we need to confirm that velocity source should be in single well, and then for the sample intervals, you just let it constant, and then look at this display parameters. It will be starting from domain -100 to the -100 to the end of 800. So you can I confirm the parameters before select the set, and then select this save, and then there will be automatically saved there. And after that, we select the angle gather, and then the other screen will be pop up, and then we need to confirm that the input and the output is in the correct name, and then we let the number of angles is 11. The angle is from 0 to 43, and then we select the velocity field to the velocity field 3. After that, we look at the another advance for confirms our angle gather parameters. The first one, we're looking on the time window. We apply to the target window, which is from the best guess to the top guess. The best guess we should put a negative 50, and then the top guess should be positive 50 meter per second. And then we look into the other basic one to confirm the type of our parameters, and then from here we identify the name the output value file, which is we put angle together. And then to confirm the format, it should be SEGY format. And to confirm again, you can look at the summary. Say, and then you can run and save. After that, after that we need to select the wells. The well should be AVO well as we said before. Then we select it as our well. Then this window will be generate. And then after that, we need to select our horizon. The the horizon we pick is a best guess and then the top guess. So just click the select, and then that will be showing in the our screen. So the next step I will pass to Kumaira for the more details.
Okay, hi, my name is Myra. So I will be presenting the next half of the pre-stack inversion process. So you can start off with selecting extract seismic wavelet. So here our input, we will be using the angle gather and our wavelet name statistical from seismic. We make sure that our wavelet length is 200 meters second. And we're just making sure that we use the entire trace. So after that, we go to advanced options and make sure the taper length is 25 meters second. We make sure we click our events. So then we select save, and then we move on to correlating the wells. So over here, we have already actually correlated the wells. We're just making sure that all the data is there. So once we have made sure that all the data has been selected, we just click OK. And then we build the initial model. So select build initial model. We are building the pre-stack. Make sure we are using, we will be naming our model model 1. And then make sure our well is AVO well and our horizon is top gas. For reference grid, we'll be using the super gather as our reference. Then we go to advanced. We'll be creating a new blank model and our model name is model 1. So let's go to next. Make sure it's typical pre-stack inversion. And again, we check that we use the correct well. And this is where our reference grid using the super gathers. And then next, this one we will select our logs. So make sure our logs are density, P impedance, P wave, S impedance, and S wave. And click next. And then this is our AVO, and we select the active, showing the active logs for all the columns. So we make sure that all of them are correct, and we go to next. Then here we make no changes, and these are our selected horizons and our high cut frequency at 10/15 Hz. So we click OK, and then our initial model will be built as shown. So this is our initial model. Then we will go to running the inversion analysis. So we use the angle gather as our input, using the entire trace, entire range. So we're using our AVO well as our well. And our wavelet, we must make sure to use the statistical from seismic, which we created earlier. And then next. This one is our pre-stack parameters. We just use the one that is already selected for us. And then next is our log curves. We don't change anything. And then we just keep everything the same except for this one. We make sure that it is our base gas and our top gas. So our base gas will be negative 50 and our top gas should be positive 50. So we don't make any changes here, then select OK. So here is our inversion analysis, as you can see. And finally, our last step will be apply to volume. So select. So we selecting apply to volume. Our input is angle gather, and we're using model 1. So here's our preset parameters which we don't change. We go to advanced options to make sure that all is correct. Our windows, our range, the output, the format, and you can also see the summary as well. So click run and you'll run the entire preset inversion. So here is the preset inversion for P impedance and inverted ZP. So then you can see at where our top gas and base gas is at. That is our inverted properties. So from here you can also play around with the other parameters that we have created. So for example, you can go to the project data under model, and you can see under model 1 we have P wave, density, S impedance, S wave, S impedance, and synthetic, which we selected previously for our logs. So for example, if you want to look at other models such as model density, you can select the model such as model density, and when you select, you can drag it down into a new view. So you can put it as view 3 and you don't close the existing data and select OK. So here then now you have 3 windows. So with that you can compare between each model with their inverted properties. So this is the last step for the preset inversion process. Then you'll be moving on to how to identify the reservoir from the cross plot, which I will pass it on to Enoch.
Thank you, Kumaira. My name is Enoch. On this tutorial, I'll be showing you how to identify the reservoir from the cross plot. So is the video playing? Okay, soon we shall be able to see the cross plot. Can you forward it a little bit? Yes. So right here is the cross plot. The provided cross plot, this two shows the relationship between two variables, which is the P impedance, as we can see on the first and on the second graph, the P impedance and the VP/VS ratio. Both graphs exhibit a negative correlation, and then they're indicating the variable as one variable increases, the other one decreases. So as we can see here, I'm trying to adjust the plot correctly to be in the middle so we can be able to correctly pick our reservoir. So as we can see down here, there are very many parameters that we can be able to adjust from the P impedance and then the original log. So here, if you adjust, you want to make sure that your line is in the middle of the data, so you can be able to correctly identify where your reservoir should be. So the purpose of the negative correlations, as we have seen in this on these both graphs, suggests that there's a systematic inverse relationship between the P impedance and then the VP/VS ratio. This could be due to some underlying issues in reservoir or so. But finally, as we can see here, this is a very simple cross plot, and we are easily able to identify our reservoir here. So this brings me to the end, and I will pass it back to Oscar to conclude this tutorial video.
Thank you, Enoch. In our project, we explained the process step by step and briefly from pre-stacked inversion analysis process to using crossplot between inverted properties to identify the reservoir. We also showed why it's important and why it's important pay attention to those parts. In conclusion, I would like to say in our project, all the members of our group do their work actively and help each other. Thank you for listening, everyone. Goodbye.